Hello everyone, I am Dr. P. Timothy, Associate Professor of Mechanical Engineering. Today I will give the complete information about the naval ship. If we take the naval ship, on a naval ship what is the effect of gyroscopic couple, I will tell. Before that, first I will tell the terminology which was used in the naval ship. For example, you see this diagram. This is the naval ship, and here the terminology, if we see, this is the front end, we call it as a bow, and this is the rear end, this we call it as a stern or aft. This is the terminology. Front end we call it as a bow, and the rear end it is a stern or aft. And when for example, if I am taking this as a naval ship, this is a bow, front end, this is a stern, and if I stand like this, from here, my left hand side, this is called port, and right hand side, this is called starboard. You see this in this diagram. From here, left hand side portion we call it as a port, and this right hand side portion we call it as a starboard. This is the terminology we are used in the naval ship. Based on the terminology, now I will explain what is the effect of reactive gyroscopic couple in case of a naval ship. In a naval ship, for example, the ship is moving in the water. It has three types of movements. Water means, you see, this is the naval ship. It is moving in the water. When it is moving in the water, first movement it is steering. Steering means it can steer left turn or it can take right turn. Left turn or right turn. This is the steering movement. And because it is moving in the water, it can pitch like this, up and down, pitching. This movement we call it as a pitching movement. Pitching upward, pitching downward. Pitching upward, pitching downward. And it has another movement, third movement, that is a rolling. Rolling means it can roll like this. This is the rolling movement. It means whenever a ship is traveling in the water, it has three movements. One is steering left and steering right. Another movement pitching up and down. Another third movement pitching, rolling. Third movement rolling. These are the three movements. Now we have to discuss what is the effect of reactive gyroscopic couple when the ship is steering left turn or right turn. And second moment, what is the effect of reactive gyroscopic couple when the ship is pitching, and again in case of rolling how it will be, that I am going to discuss now. For example, first I am discussing about the steering movements. You see here, conditions are very important. So first I am taking one condition. Now you see this is the steering moment. Condition is given to you. Rotor rotates in the anti-clockwise direction when viewed from rear end, and the ship is taking the right turn. These are the conditions. Rotor is rotating in the anti-clockwise direction when viewed from rear, and the ship is turning right turn, is taking right turn. Now I will explain like this. To tell the effect of reactive gyroscopic couple, because of these movements, I have to draw the angular momentum vector. How to draw the angular momentum vector? If you see, now this is the ship, naval ship, and this is the front end, we call it as a bow. This is the rear end, we call it as a stern or aft. This is the terminology. The condition is given to you. When viewed from rear, the rotor of the ship is rotating in the anti-clockwise direction. then I have to shift that viewing direction from rear to front. When I observing from front, the same thing will be, the rotor will be rotating in the clockwise direction. It means, you see, from here I am observing rotor is rotating in this direction, clockwise direction. So clockwise direction means first vector, you see this is the clockwise direction. I have to take my, with the help of right hand screw rule, we have to draw this. I am taking my right hand. Now it is rotating in the clockwise direction like this. I have to close my four fingers of my right hand like this. Like this. Now my first vector direction will be like this, in this direction, from here to here. From here to here. So that same thing I have drawn here, you can observe this. From here to here. This is the first vector direction, OX. Now I have to stand at the starting point of the vector. Now I will see whether it is turning left turn or right turn. As per the condition it is given that the ship is taking right turn. It means from here, it is, this is the left turn and this is the right turn. Left turn and this is the right turn. So I have taken like this. This is the right turn. So after drawing OX and OX dash, automatically XX dash gives you A, means active gyroscopic couple direction, and this R means reverse X dash to X. This is the reactive gyroscopic couple direction. Now I have to decide what is the effect of this naval ship because of this. How to decide means, you see, whenever the axis of spin and the axis of precision both are perpendicular to each other, then there is a possibility of forming a gyroscopic couple. In this case, if I observe, this is the naval ship, now the rotor is rotating in the clockwise direction when viewed from front. It means the axis of spin will be like this, and when the ship is taking a left turn or right turn, whatever it is, the axis of precision will be like this. This is axis of spin and this is axis of precision. Both are perpendicular to each other. Then automatically on the third perpendicular plane, this blackboard is the reactive gyroscopic couple plane. On this plane there will be gyroscopic couple. So how to decide means, based on this diagram, I have drawn this diagram. Now I got active gyroscopic couple like this, reactive like this. So these two directions will be perpendicular to the blackboard. It means will be like this. Perpendicular to the blackboard will be like this. When I observe in this diagram, active gyroscopic couple direction is towards the blackboard, and a reactive gyroscopic couple direction, this is away from the blackboard. It means to decide the effect of reactive gyroscopic couple, I have to consider R direction here. This R means this is away from the blackboard like this. Now what I have to do, this is like this, away from this. What I have to do means, again I have to take my right hand. I have to show the direction of my thumb in the direction of R like this. It means like this. Now the ship will be tilted in this direction. My four fingers, you see, in this direction the ship will be tilted. When the ship is like this, and I am this because of this effect, the ship is going to tilt in this fashion. In this fashion means, you see, this bow is rising, stern is dipping. It means the effect of active gyroscopic couple, as per the given condition, it is to rise the bow and to dip the stern. This is the effect of active gyroscopic couple in case of a steering, as per the conditions we have taken. And another moment I will explain, that is a pitching moment. Pitching moment, already I told you, whenever a ship is traveling in the water like this, the ship is going to tilt in this fashion, pitching upward and downward. This we call it as a pitching motion. In this pitching motion, if I observe, you see, this is the naval ship, rotor is rotating like this. Now my axis of spin will be in this direction in case of pitching. Whenever the ship is pitching like this, pitching like this. This is the plane of precision we call it as. Now the axis of precision will be like this. In case of second moment I am explaining, whenever the ship, if we consider the pitching moment, when the rotor is rotating like this, then axis of spin will be in this direction, and because of pitching, axis of precision will be like this. Both are perpendicular. Now my reactive gyroscopic couple plane is this floor. So this is the floor, and now I have to see the active and reactive gyroscopic couple direction from which are perpendicular to the floor. This also I will explain with the help of the diagram. Here I have taken the conditions like this. You see, this is the pitching moment. Conditions: rotor is rotating in the clockwise direction when viewed from stern, means from rear end, and pitching upward. You see, now I will explain. Ship is like this. Rotor is rotating like this, clockwise direction when viewed from rear. Now I am observing from front. Whenever I am observing from front, it is rotating in the anti-clockwise direction. Now with the help of right hand screw rule, this is the anti-clockwise direction. Now it will be like this. The first vector direction will be like this, towards myself. So I have drawn this. You can see this in the diagram. This is the OX. This is the OX. Now, from starting point of the vector, this is pitching upward, and if it is downward, it will be like this. This is pitching upward. Automatically, XX dash gives you active gyroscopic couple vector direction, and X dash to X gives you reactive gyroscopic couple vector direction. Now to tell the effect of reactive gyroscopic couple, I have to consider R direction, and in the beginning itself I told you, in case of pitching, the reactive gyroscopic couple plane is the floor. How it is floor? Once again I will tell. You see, whenever the rotor is rotating in the direction like this, this is the axis of spin, and whenever the ship is pitching in this direction, in this fashion, now the axis of precision will be like this. Now automatically active and reactive will be like this, which are perpendicular to the floor. Now I will tell the effect with the help of the diagram. Now my diagram, if I observe, active will be upward, will be like this. Reactive will be downward, will be like this. I have to tell the reactive gyroscopic couple effect. It means I am taking, you see, my right hand side. Reactive will be like this, downward. Reactive will be downward as per the diagram. It means what I have to do, I have to take again my right hand. I have to show my thumb in this direction. Now my four fingers of my right hand will be turning like this. It means the ship is trying to turn in this direction. So in the terminology I told you, if it is the ship, this is the port side and this is the starboard side. So based on these conditions, I can say that the effect of reactive gyroscopic couple is the ship is to turn towards the starboard. This is the effect of reactive gyroscopic couple in case of pitching second moment. And coming to the third moment, that is rolling. Rolling, I told you, if this is the naval ship, so this is rolling. Because of water, ship will roll like this. And the rotor is also rotating in this direction. Now, whenever the rotor is rotating in this direction, this is the axis of spin. And because of rolling, again, the axis of precision also same. It means what is going on? The axis of precision is coinciding with the axis of spin. Whenever these two axes are coinciding, then there is no effect of reactive gyroscopic couple in case of a rolling moment. Because as per the gyroscopic principle, whenever the axis of spin and axis of precision both are perpendicular to each other, then only there is a possibility of forming a gyroscopic couple. So from this we can conclude that in case of a rolling of a ship, there is no effect of reactive gyroscopic couple. So this is the explanation about the effect of reactive gyroscopic couple in a naval ship. Thank you very much. I request all of you, please like and subscribe my channel. Thank you.